Hey, hello there, welcome to CS School channel. In this video we are going to look at first and last occurrence of elements problem. This problem is asked a lot of time in different coding interviews. As usual, the link of this problem is in the description of this video, so do check it out and try to solve it on your own. If you can solve it, come back to this video. So now let's look at the problem statement which is given on the screen. Given an array of integers nums sorted in non-decreasing order, find the starting and ending position of the given target value. Okay, so we will be given an array of integers which is sorted in ascending order, and we need to find the starting and ending position of a target value which will be given to us. Okay, if the target is not found in an array, return -1 -1. Okay, and you must write an algorithm with an O of log n runtime complexity. Okay, so let's look at some of the sample inputs and outputs. The first input is an array with the numbers 5 7 7 8 8 10, and target given to us is 8. Okay, so what's the starting position of the 8? It's 0 1 2 3, right? So this 8 will start at position 3, so we are returning 3 as the first element. And what is the ending position of the element 8? It will be 4, right? So we are returning 4. So 3 comma 4 is the final output result. Okay, similarly let's look at this. We are given and target 6. Okay, so the 6 doesn't exist in the array, so we are returning -1 comma -1. Okay, what would have happened if we have given the target 7? It will be 0 1, so the starting position will be 1 and the ending position will be 2. Okay, so that's what we need to do. So hope you are clear with the problem and the sample inputs and outputs. So now let's look at the first approach, which is a brute force approach for solving this problem. Okay, so this is the array which is given to us and the target. So the target is 8 for us. Okay, and we need to find this target, the first and last occurrence of this target in this array. Okay, so what we will do, we will keep two variables: first occurrence which will be initialized with -1 and the last occurrence which will be initialized with -1. Okay, then we will iterate over all of the array. So we will start with 5. We will check this 5 with the target. Is it matching? No, right? In this case, move to the next element. Now check this 7 with 8. Is it matching? No, move to the next element. Check this 7, not matching with the target, move to the next element. Okay, now this 8 is matching with the target. Okay, and then we will check the first occurrence. Is it initialized to -1? Yes, then we will initialize the first occurrence with the index that we are currently on. So we are on 0 1 2 third index, right? Then we will set the first occurrence to 3. Then we will set the last occurrence to 3. Okay, cool. Then we will move to the next position. Okay, now this 8 is also matching with the target. Okay, in this case we will check, is the first occurrence equal to -1? No, right? Then we will not set that first occurrence. That means basically the first occurrence is already set somewhere previously, right? So we will not change for first occurrence, but we will change last occurrence always. Okay, so we will set last occurrence to 4 now, and then we will move to the next element. Well, the next element is not matching with the target and we are at the end of the array, and at the end we will return 3 comma 4 as the result in an array. Okay, so hope you are clear with this approach. Now what's the time complexity of this approach? So let me just write time complexity. So what will be the time complexity of this approach? Well, as we are running one for loop over the entire array, the time complexity becomes O of n, right? And what's the space complexity? Well, as we are not using any extra space, the space complexity becomes O of 1. Okay, so hope you are clear with the brute force approach. Now let's optimize this approach a little bit so that we can achieve the expected time complexity of O of log n. Now let's think about how can we optimize the last approach. So if you have observed the problem, you know that array is sorted, right? And we need to find the element in the array. Which is the algorithm which helps in finding a particular element in a sorted array? It's binary search, right? So can we use binary search to solve this problem? Okay, actually we can. There is a way. Okay, so to use binary search, we need to divide this problem into two different parts. First part is finding the first occurrence of an element. Okay, and the second part is finding the last occurrence of an element. Now let's look at how we can do that. Okay, so we are first going to look at how to find first occurrence of an element using binary search. Okay, so for that let's say you are finding element 8 in the sorted array, okay, and by doing binary search, like by finding the mid, you have landed on this element, okay. Now is there a possibility that this is the first occurrence of an element? Yes, this could be the first occurrence of an element. Is there a possibility that the first occurrence can occur before this element, like at this position or previous to that? Yes, there is a possibility, right? Array is sorted and we have 8 here. We can have 8 here or 7 here, right? But there is a possibility that 8 could be here, right? So in binary search, we actually stop after finding the element. Instead of that, what we need to do, we need to start searching in the left half of the current element, okay. So in binary search, we used to stop after finding the element, but here what we need to do, we need to search in the left hand side of the array, okay, to get the first occurrence of the element, okay. So let's see how it works in practice. By the way, if you don't know binary search, there is a video on our channel you can watch and understand it, so I will link that video in the description, okay. So now let's start with the approach for solving this problem. So we have taken this array in which we need to find 8, okay. We will initially start with 0 and end with 5 because there are 6 different elements in this array, okay. Now we need to find the mid, which is start 0 plus 5 divided by 2, okay, which gives us 2.5, and we need to take floor of that, which gives us 2, okay. So we go to the second element 0 1 2, okay. So here are we. Now we compare 7 with 8. Are they matching? No, right? In this case, what we do in binary search, we increment start to mid plus 1 because 7 is less than 8. So our 8 must exist in the right hand side part. So in that case, what we do, we increment start to mid plus 1, which is 2 plus 1, 3. Okay. And then again, we just calculate the mid. So let me do that. So we do 3 plus 5 divided by 2, which gives us 5 plus 3 is 8 divided by 2. Okay, so we go to the fourth position 0 1 2 3 4th, okay, at this position, okay. So we check, is 8 matching with the target? Yes, it is. All right, and then we store that index somewhere. So I will take another variable called as first occurrence, and I will initialize that with mid, which is equal to 4, because we have found the element at the fourth position, okay. Now we know that 8 has occurred here, and there is a chance that 8 can occur before this element as well, right? So in this case, we need to search in the left hand side of the array, right? And for that, in binary search, we do end is equal to mid minus 1. Similar thing we need to do here. We need to set end is equal to mid minus 1, which is equal to 3. Okay. So mid is 4, 4 minus 1, 3. So basically now our start is here and end is also pointing to here. Okay. So again, we calculate the mid. So let me just do that. So start is 3, end is 3 divided by 2. 3 plus 3 is 6 divided by 2, which is equal to 3. Okay, so I have reached to this position using mid. Now I compare nums of mid with target. Are they matching? Yes, they are matching. So I will set first occurrence to the mid now. Okay, so see, our first occurrence was 4, now it has changed to 3. Okay, so the actual first occurrence in this array. Okay, and after that, we again start checking in the left hand side of this array. So what we will do, we will set end to mid minus 1. Now the end becomes 2. Okay, and there is a condition at the start of the binary search that start should be lesser than or equal to end. That is failing here, and we will come out of the for loop. Okay, so in overall binary search, we need to actually make only one change, and that change is something like this. If nums of mid is equal to target. In this case, in binary search, we always used to return mid. But here, what we need to do, we need to set first occurrence to mid, and then we need to search in the left hand side of the array, right? So for that, we need to set end is equal to mid minus 1. So that's the only change that I need to make in the binary search to get the first occurrence of element. Okay. So hope you are clear with how to get to the first occurrence of element using binary search. Now the interesting part is, what's the time complexity of this entire solution? Well, we are using binary search only and we are not running any linear search. The time complexity is actually O of log n. Okay, so we have found the first occurrence in O of log n time complexity, and the space complexity is O of 1 only, as we are not using any extra space. Okay, so hope you are clear how to find the first occurrence of element using binary search. Now let's look at how to find the last occurrence of element. Now let's look at a case where we need to find the last occurrence of a particular number. Okay, so let's say we are here at 8. Okay, by doing binary search we have come to this number 8. Okay, now is there a chance that 8 can occur after this? Yes, there is a chance that 8 can occur after this, right? So instead of stopping here, we will start searching in the right hand side of the array. Okay, for the first occurrence we need to search in the left hand side of the array. For the last occurrence we need to search in the right hand side of the array. Okay, so there is actually one change which we need to make in the first occurrence algorithm. Okay, so here is the first occurrence algorithm. If nums of mid is equal to target, then we set first occurrence is equal to mid, and we set end is equal to mid minus 1. This is for searching in the left hand side. Instead of that, what we need to do, we need to set start is equal to mid plus 1. So this is for searching in the right hand side of the array instead of left hand side. Okay, and we will take another variable called as last occurrence, which will store the value of the mid. Okay, so hope you are clear how to find the first occurrence as well as last occurrence using the binary search. Now let's look at the C++ implementation for this. So here is the C++ function that we need to complete, in which we receive vector of nums as an input and a target, and we need to return vector of integer with the first occurrence and the last occurrence. Okay, so if you see, the code is very simple. We are calling two functions, get first occurrence and get last occurrence. We are storing that as an array and we are returning that array. Okay, now let's look at the get first occurrence method. So here is the get first occurrence method, which receives vector of nums and target. Okay, we initialize start, end and a first occurrence variable with -1. Okay, and then we run a while loop, which is a condition for a binary search. Start is less than equal to end. Then we find the mid by adding start plus end and dividing it by 2. If the nums of mid match with the target, in this case we set first occurrence is equal to mid and end to mid minus 1 to basically search in the left hand side of the array. Else if nums of mid is lesser than target, that means the target exists in the right hand side of the array. In this case we set start to mid plus 1, just as in binary search. Okay, and in the last case we set end is equal to mid minus 1. Okay, so hope we are clear with the get first occurrence method. Similarly we are doing with the get last occurrence method. In this case the change is just 2 lines. Okay, we are setting last occurrence is equal to mid and we are initializing start with mid plus 1 to search in the right hand side of the array. Okay, for running this code I have written a main function which has defined vector of integer nums and a response. Okay, which calls this search range function, and it needs to find this 2 in this nums array. Okay, and whatever the result is, I am printing the first occurrence and the last occurrence. Okay, so now let's just run this code. So we get 1 and 4 as output. So if we check, 1 is the first occurrence of 2 and 4 is the last occurrence of 2. Okay, so hope you are clear with this problem and its solution. If you have any doubt, do ask me in the comment section. I will be more than happy to help you. We'll be making more such videos in the future, so stay tuned for further videos and do subscribe to our channel. It helps us to stay motivated and make more such videos.